Hello everyone. So today we will be discussing about packing efficiency. Okay, so what is packing efficiency? As we have already discussed in solid state, when we are arranging the particles which we assume as spherical in a way that there has to be minimum space, this is known as close packing. Now when we are putting the particles in close packing, some of the space is occupied by the particles and some of the space will still remains unoccupied. So this packing efficiency is basically the space occupied by the particles when we are arranging the particles in close packing structures. Okay, so today we will be discussing about packing efficiency for face-centered cubic unit cell. As we know that face-centered cubic unit cell is also known as cubic close packing structures. Okay, as we have already discussed in close packing or the close packing arrangements, that there is CCP, cubic close packing, which is equivalent to face-centered cubic. Now what is face-centered cubic unit cell? The FCC unit cell is the unit cell in which the particles are present at the corners, as we have written here already, and the particles are also present at the face center. When the particles are present on the corners as well as on the face center, then that is known as face centered cubic unit cell. Now how can we calculate the value of packing efficiency for that? First of all, we will calculate the value of total volume of this unit cell, then the volume of particles which are present in this particular unit cell. Then we divide these two and then we'll get the packing fraction, multiply by 100 will give us packing efficiency. Now if you have to calculate the value of volume, we have to calculate the value of A in terms of R, where R is the radius of this spherical particle. Okay, so for that I'll be joining A to C, and there is a particular we can say there is a triangle form, that is ABC here. This ABC triangle is having AB as A and BC as A, which is a right angle triangle. So we can apply the Pythagoras theorem here, and that is AC square is equal to AB square plus BC square. Now when we are applying this particular Pythagoras theorem here, you can see that AC square is equal to A square plus A square, which is giving us 2A square. So AC, or the value of this particular diagonal, which is also known as face diagonal, the value of this face diagonal is root 2A. Now we are having the value of root 2A, and the particles, as you can see, are arranged. When I am writing this AC, the one of the particles at the corner is like that, and one which is as a face center is like that. Now if it's the value of this AC is, as we have calculated, is root 2A earlier. Now you can see if R will be the radius of this spherical particle, R is also here and 2R is here. Now the total value of this particular whole AC is 4R, and 4R is also equal to root 2A. As I mentioned here, 4R is equal to root 2A, and if you calculate the value of A is equal to 2 root 2R, and we know that volume of this particular cube is A cube. And if we're applying the value, if we're putting the value of A as 2 root 2R cube, this is equal to 16 root 2R cube. Now as we know that the number of particles in FCC, how can we calculate the value of number of particles? As we know that the particles are present at the corner and also at the center of the faces, and we know in FCC the corners contribution of each particle is 1 by 8, and total number of corners, as you can see, 4 corners up and 4 corners down. Okay, so total 8 corners are there. And if we'll talk of face centered, there is 6 face centered. One is above, below, one is here, one is here, one is at the behind, one is at the like on the other side of that particular cube, you can say. So the contribution is 1/2, total 6 cubes. So total number of particle in FCC is 4. Okay, if total number of particles is 4 and the volume of one particle is, as it is spherical, so 4/3 pi r cube. So total volume is 16/3 pi r cube. Okay, now if we'll calculate the packing efficiency value, how can we calculate? We will divide this. Okay, we will have the volume of the particles and total volume. Volume of particle is 16/3 pi r cube divided by total volume is 16√2 r cube. How can we calculate? We have calculated earlier. Total volume multiply by 100 gives us the value of packing efficiency. Pi/3√2, if we will be solving this particular value, will gives us 74%. So the packing efficiency for face centered cubic, or the percentage of space occupied by the particles, is 74%. If we know the value of percentage of occupied space, we can calculate the value of percentage of space unoccupied. What we will do? We will have the value of occupied space. We will subtract it from 100, and if we will subtract from 100, we will get the value of percentage of space unoccupied as 26%. So in this way we can calculate the value of packing fraction or packing efficiency for face centered cubic unit cell. In the same way we can calculate for body centered cubic or simple or primitive unit cell also. Okay, so this is it for today. We will be meeting in the next class with the next topic. Thank you, students.